Hello, and thank you for joining us today. In the next half an hour, Helmut and I will show you how to create a data dashboard to explore a data set and visualize it using Julia and Genie. I'm Adrian. I'm a software developer with over 20 years of experience creating full-stack data-centric web applications, and I'm the creator of Genie Framework.
Hello, my name is Helmut Hänsel. I come from Germany and I work as a data scientist with a Merck company in Darmstadt.
Today we'll create a data application, a data dashboard, that will help us explore a data set of movies that have received Oscars. Looking at the data, some of the columns that we'll be using are the title of the movie, the year when the movie has been released. They start in 1927, and we have the latest entries in 2013. We have the genre, which is a comma-separated list of words. We have the director, which again is a comma-separated list of words. The same for the cast, the IMDb rating, the language of the movie, the country where the movie was made, as well as the awards and the number of Oscars that the movie has received. And here you can see exactly how we're going to use this data. This is the data dashboard that we're going to create today. Here we have a data table of all the entries in our database. And here we can apply various filters. They correspond to the columns that we've just seen. We can filter by the minimum number of Oscars, by the year when the movie was released, by the country, for instance, USA, by genre. And we can see that our data is updated in real time. And also when we hover over the various data points in the plot, the movie details on the right-hand side will be updated. And this is what we'll use to create our data dashboard. From the Genie framework, we're going to use the Genie and the Steeple Julia packages together with a couple of plugins, as well as the SQLite and the data frames packages. These are all free and available, readily available in the Julia registry, so you can just install them in the regular way. We will also use the Genie Builder Visual Studio Code plugin, which is available in the Visual Studio Code marketplace, as this plugin greatly simplifies the development of Genie apps in Visual Studio Code.
Let's begin. Here I have Visual Studio Code with the Genie Builder plugin, providing this pane for managing Genie apps. I'm just going to start by creating a new app. We're going to call it Oscars Explorer. My app is now being created. Our app is ready, and I'm now being asked if I want to start it. Let's say yes. Once the app is loaded, we can see here some of the most important parts of our application. Here we have the model, and we will discuss about it in a few minutes. Here we have the view, which is where we will develop the user interface of our data dashboard. And here is the layout of the application, which controls the general look and feel, but we will not be making any changes into that file. Let's start by creating the user interface of our data dashboard. We will use the no-code editor, which allows us to visually create the UI of our application. Remember, this is what we're looking to build. We want to have a header here. We want to have 3 columns. And then on the left-hand side, we want to have multiple filters. In the center, a plot and a data table. And here, a series of details for the selected movie. This is what our application looks like right now. This is just some placeholder code that has been created by Genie when we set our application. And actually, we can already access it as the application is running. So this is what it looks like. And we can start making changes here in real time, and we can see them reflected as we work. So first of all, we said that we want to add a header. Let's go ahead and place it here. We're going to name this Oscars Explorer. Next, we want to add 3 columns layout that will host the 3 sections of our app. And then we want to start creating the various parts of our data dashboard. We will use this title plus content block, which allows us to set up these pairs. So, for instance, here we want to have the minimum number of Oscars, minimum number of Oscars. And here we want to have a slider. In the center, we want to put the plot and the data table. We have our plot here and the data table. And here on the right-hand side, we want to have more of these pairs of heading plus text. So we're going to use more of these. Actually, this one is called the title. We can have more of these. We're going to say year, and here we're going to display the year a bit later in the application. Let's save it, and we can see that the changes have already been applied here. Now, it will take me about 10-20 minutes to finish the user interface and polish all the components to have a nice looking UI. Unfortunately, due to time constraints, we won't be able to go through the whole process, but I would just speed it up. However, if you want to see more of the details, we will provide additional resources, including a longer video that covers the whole process, as well as a step-by-step guide, together with the materials that we will be making available for the conference talk. That's really everything in terms of UI building. It only took us 5 minutes to create this whole user interface. But of course, these inputs now, they don't do anything. So the next step is to bring the data into the application, to write the backend, write the data functions, and then connect the user interface to our backend. By convention, we are placing all the code related to data manipulation into our model file, which is the Oscars module placed inside the models folder. To gain some time, I have already populated the file with the code. Just looking over it very, very quickly, here we can see how we connect to the database. Here we define the constant for the data table options, which sets the columns that we want to show for our data table here. For the Oscars range, we retrieve the minimum and maximum number of Oscars in order to set up the boundaries of this slider. For the years range, again, we extract the minimum and the maximum years in order to define this range between 1927 and 2013. And the movie data function retrieves the data for our various dropdowns on a column by column basis. So it helps us populate these ones for here. Then the Oscars function aggregates various filters in order to apply the input from the various UI elements and run a query which updates the data, which is then being rendered on the page. Now that we have the data functions and the user interface, it's time to develop our model. The model is a struct, it's a subtype of reactive model, and this instance is how we communicate with the front end. By using a model, by using fields of the model, we communicate, we tag what parts of our data we want to make available to the front end. And this data can be made available either as a reactive property, which means that we have two-way synchronization, meaning that we expose the value from the backend onto the front end, but then if the value is being modified on the front end by means of interacting with the various user interface component, we then retrieve these changes onto the backend, or we can expose this data as read-only properties, something that we expose from the backend but cannot be updated from the front end, or we do not subscribe to updates when the data gets changes. So for instance, in this case, we set up these various filter properties which we want to use as the values of our filters in the left-hand column, so that we display what values the users can select there, but we also get notified when they manipulate the various filters, right? So let's take a look here. For instance, we have these filters Oscars, which is used here, and we see that its default value is the start of the Oscars range, which is 1. And then every time I change the value here, this value on the back backend, the filter Oscars also gets updated with the values that is currently selected on the front. And the same is true, for instance, for the ears release range. Every time the user manipulates these values, the filter's ears on the backend will be updated to reflect the changes introduced on the front end. While here, for instance, we have various collections which are exposed to read-only data, as for instance, these countries string, vector of string, which is used to populate the list of countries here in the dropdown, or the genres or the directors of the cast, which all fill up their various the various options in their selects. In close connection to the functionality of the model is this handlers function, which we can see that actually takes an instance of our model as its argument. And what this handler function does is that it is being called, it is being executed every time these reactive properties are being changed from the front end. So here we declare that we are watching these reactive properties, and every time they change, by means of their reactivity, their value is being synchronized with the backend, and we are notified that their values have changed, and these handler functions are being triggered. And what do we do in response to that? We take the current values as they are being set up from the front end. We run a query against our data to filter and to bring only those entries that match the filters applied from the front end. And then with this list of data, we update the data table. Now that we have all the components of our applications, our user interface, our data access functions, our model, and our handlers, it's time to put everything together by going back to the no-code editor and setting up the bindings between the user interface and the model so that we can connect what the UI displays and how the backend responds as the UI is being updated. We set up these bindings by connecting the various properties of our UI elements to their corresponding fields of our reactive model. So for instance, this slider, which corresponds to the number of Oscars filter, if we go here in its settings, we will want to connect it to the filters Oscar property of our reactive model. Or for instance, this plot, we will want to connect this data property to the data field of our model, and its layout property again to the layout field of our model. And if you remember, we defined this here, filter Oscars and the data and the layout. Another way to set up the bindings is to use the mustaches syntax to embed references to our model. For instance, in this case, we want to show the details about the selected movie, which is here, being a dictionary. We can just go ahead and remember the name of our variable is selected movie. So we can go here, and within double mustaches, we can say selected movie title, or we can say selected movie year. And again, this will create a binding between the property of the model and the UI. And in the same way, from the no-code editor, I can set and control other properties of the UI elements. For example, for the filter Oscar slider, I can make it snappier as I drag and drop it, or I can even embed Julia code. So I can say something like Oscars. Let's see, we want to reference our Oscars range. So we want to say that the minimum one is Oscars range start. And then for the maximum value, we want to reference the same one. We want to say Oscars range stop. And of course, we can set up other properties. It's good to have, for instance, the label to show the value that is currently selected on the slider. And we want to always show it. And it's also good to show markers, which are the dots which mark the individual labels. And I think that's all for now. Let's see what it looks like. So we can see that our changes have been applied, and our dashboard is starting to look already much closer to the one we're looking to develop. And we need to do the same process in order to configure the bindings for all our UI elements in order to connect them to the user interface and enable their reactivity. Due to the lack of time, I will just go ahead and set up all these bindings on my own and get back to you when I'm done. Again, you can watch the long version of the video in the links and the resources that we'll be sharing, as well as the step-by-step guide of how to build the application yourself. All right, I'm back. I have completed setting up the bindings for all our UI elements. We can see now that all of them are properly configured. And if we save it, we can see that our page is being reloaded and our data dashboard is now complete in terms of filtering and displaying the data. So that was everything.
Let's directly jump to the editor here. And let's go to the table first and highlight the two fields that have been introduced to make synchronization of selection possible. We have to tell it that multiple selection is possible, and we define the field that the selected fields should be synchronized to. That's all for that. In order to make the plot reactive, I introduced this class data. This needs to be put in class, prefixed with sync underscore, and then the following name data is the prefix for the fields that will receive the plotly events. So let's go here to the core of our model. Let me highlight here the field that we have introduced that receives the data table selections. And here some new fields: data selected, data hover, data click, data relayout. Actually, there's a shorter syntax that I will just show to you. This is the mixin. This is a macro that allows to paste in a structure. The structure is defined here in charts. And the lines that are defined here in the structure will just copied to your model, prefixed with data. A very convenient syntax to write. If we have done this, we need some more detail in order to make the plots really reactive. We need to call a routine that watches all the divs and then synchronizes the plots as soon as they appear. This is just the one line, nothing more is necessary. So after this, we have to put our handlers in place. Let us have a glimpse first on the onAny. This is a classical selection field, I would say. It relies on all the different inputs on the left-hand side that we saw in the mockup. They receive different parameter names, and they build up a SQL statement. It's checked for validity and then passed to the database as a query. From the answer, we build a data table and assign it to the model field movies. So now that the data table is in place, we also want to supply the plot. We calculate a plot data from the database, and the data frame that is attached to the movie is just available under .data. A model layout is also in a very similar way assigned with x-axis title and y-axis title. And we're done. Let's have a look how that is live. So we can choose here the years where we are interested in, and as soon as we change any field here, it will react and reduce the data set. Or if we want to have less Oscars, then of course we have less Oscars. But now let's come to something interaction with the plot. I told you the field data selected receives all selection events from the plot. And it receives a dictionary structure, and that contains the field points. And in the points, we have all the plot indices listed of the plot points that have been selected. And there's a routine that selects rows in a model. If the model has a table that is called movies, it will select all the fields of these movies. So this in action. Let's try. Go to the selection box and just select 2 points. And indeed, we have 2 records selected. We scroll down, we find the second one. And if we select more, this has not worked. I've lost my selection. Then we get all these points. We can also select in the table and see that the plot points are appearing when I tick these here. And this is achieved by the handler here, a bit more down. It receives the selection, as I told you. We linked this in the very beginning. And then in a very similar manner, I get from the selection the IDs of the rows that have been selected. I put a union because I have two data sets, and each one will be giving an index, so I just reduce it. And then I loop over the two traces that I have in the plot. And now I have something very interesting here. Actually, I could have done it in the back end, but here I show you something how I do it in the front end. If I give an index, which is a string, this will not index the model on the backend side, but on the JavaScript side. The syntax is very similar. In JavaScript, you can always go one level lower with dotting something. I have to care for the 0-based and 1-based, but by subtracting a -1 here. And if the selection is empty, then I tell the model to have nothing selected. Otherwise, it will be just empty. I don't want this. Or I supply the array of points that should be selected. If I have done this on the JavaScript side, I need also to tell the JavaScript side that it has updated, and please send this back to the backend. There's a command, notify model, and then I have to give here an argument, which is JSON text, and this is just the name of the data field that shall be notified, and that's what it does. And you've seen that it works. Why did I do this on the client side? Sometimes it's better if I do just a selection on the client side, because normally, if I have the selection box, I don't lose my context. I will stay in the selection context. So if I do another select, I can do that, unless I update the plot from the backend side. When I update the plot from the backend side, I will be always back at the normal selection and zoom behavior. And this is what I didn't want, so that was a way to get around that. Last but not least, I want to show you the hover event in very much the same manner as selected. Data hover receives hovering events in very much the same way. I extract the index of the point I hovered over, and I can calculate the row selection, which extracts the row from the data set and puts that back in the field selected movie. And this is why if I hover over a point on the right-hand side, I always have the updated information of the plot I hovered over. This is very fast, and this is again on the backend side. I hope you like this part and see how interactive applications can get with these new developments.
Genie Builder doesn't have a user interface for managing deployments yet, so we're going to go back to using the terminal, the one provided here in the GUI. We're going to launch the REPL, and let's go ahead with the deployment. We're going to declare that we're using our deployment packages. Let's start with Genie deploy Heroku. And the first thing I want to do is to log in. Okay. We are now logged in. Now let's create the application. Create app, and let's call it Oscar's Explorer. This creates a new application on Heroku, which uses a container for the deployment method. So it will expect a Docker container in order to be put live on the server. As such, we now need to prepare our container to containerize the data dashboard that we have created. So for that, we're going to use Genie deploy Docker. And Genie comes with a recipe which creates a Docker file, which are instructions on how to containerize Genie applications. So we just need to ask Genie deploy Docker to generate this Docker file for us, and that's all we need. Now that we have created our Heroku application and we have set up the configuration for our Docker container, it's time to containerize our data dashboard and have it pushed over to the Heroku servers. We're going to do that by using Genie deploy Heroku again. Deploy Heroku, and we're going to say push, and we're going to pass the name of our app, Oscar's Explorer. This will go ahead and create the container with the application, with all the dependencies and everything that is necessary to run our data dashboard on a server in a new environment. This is going to be quite a long process, so we're going to skip it and we're going to get back to it once it finishes setting up the application. Okay, we're back. This took something over 10 minutes on my computer, and depending on the speed of your computer and of your internet, it can take less or more. Your mileage will vary, but the important part is that now our app has been containerized and the image has been pushed over to Heroku. So now we can go and release it. Again, we need to use Genie deploy Heroku, and then we're going to call the release command, and then we're going to pass the name of our application. This should be quite quick. And that's it. Our application has now been placed in production. And that was everything. Thank you for taking the time to watch our presentation.